So welcome back. Before we look at the Queen MC Klossky algorithm, which is referred to as the tabular method for simplifying our Boolean expressions, let's quickly look at a four variable K-map. Another example, assuming you are given y into the bracket of a, b, c, d, which is equal to summation of the main terms. So in this case now, instead of the Boolean expressions in terms of the variables, we have numbers that have been given. That is where our position of ones are going to be in the K-map cells. So we're given summation of the mean times 0, comma 1, comma 3, 7, 8, 9, 11, and then 15. So this, in solving this using K-map, it's a 16. We are going to end up with 16 cells. So 2 raised to the power of 4, that is 16. So how do you go about solving this using K-map, right? So let's see how this can be solved. So we have, let me draw the 16 variable cells. Rather than, let's have it this way. So I'm drawing the four variable kind of map. Four variable kind of map. So with this, we should be able to end up with 16 cells, right? In terms of the four variables. So we have the AB, right? And then CD. And then for the labeling, we have 0, 0, right? We have 0, 1. We have 1, 1. And then we have what? 1, 0. Similarly, we have at this cell, this row rather, 0, 0. We have 0, 1. We have 1, 1. And then 1, 0. So let's populate that with all the possible combinations so that we know at what point our variables in terms of the values given are going to be to know exactly where our ones is going to be in terms of the groupings, right? So at this cell, we are saying this is A bar, right? B bar, this is C bar, and then what? D bar, right? Then at these cells, we have what? We have A bar, B bar, A bar, B bar, C bar, and then D. In this cell, we have A bar, B bar, and then C, D. Because the C and D appear uncomplemented. In this cell, we have A bar, B bar, C, D bar, right? So in the second row, similarly, we have A bar, B, C bar, D bar. Following that, we have A bar, B, C bar, D. We have at this cell, we have A bar, B, C, D. We have A bar, B, C, D bar. At this cell, we have A, B, C bar, D bar. At this cell, we have A, B, C bar, then D. At this cell, we have all A, B, C, and D. At this cell, we have A, B, C, and then D bar. At this cell, we have A, B bar, C bar, and then D bar. At this cell, we have A, B bar, C bar, and then D. In this cell, we have A, we have A, B bar, C, D. In the last cell, we have A, B bar, C, D bar. So these are all the possible combinations as far as the four variables is concerned. So the next thing we need to know the positions of one as far as the numbers is given. To enable you know exactly where one's supposed to be at the zero position, 1, 3, 7, 8, up to 15 positions. To give you a clearer picture on that, you can also draw um, a truth table, right, to give you all the possible combinations to enable you know exactly where the ones each falls, right? So let's have a truth table of the four variables in terms of A, B, and C, right? So this is A, B, C, and then D. Let's have another column to represent the main terms, that's the expressions. So we have these, of course, 16 variables. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. So let's go ahead. 14, 15, and then the last one will represent 16. So let's see. Okay, let's minimize this to reduce space. Let's have this here so that we can have, let's fill it up. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, and then the last one will be our what? 16, right? So we have the 16 values. So in this case, so let's populate the table. So this will be 0, 0, 0, 1, 2. So we need 8 zeros. This is 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7. Let's see again. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? So our counting actually stops at 15. So with 0, you have what? You have the 16, right? So you don't need the last column, the last row rather. You don't need the last row because our counting starts from 0, right? So for the variable b, you are going to have 4 zeros, 4 ones, 4 zeros, 4 ones, and then it reduces like that up till the last variable, right? So for the variable b, we have 4 zeros, 4 zeros, 4 ones, like that until the last value. 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. This is 0. This is 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, then 1, right? So of course, this we are dealing with mean terms where we said 0 appears complemented and then 1 appears what? Uncomplemented. So let's write all the possible combinations. Remember what we did, it was A bar, B bar, C bar, D bar, right? This is A bar, B bar, C bar, and then D. We have A bar, B bar, C, and then D bar, right? Similarly, the next row, we have A bar, B bar, and then C what? CD. Here we have what? A bar, B, C bar, and then D bar. Here we have A, B, that is A bar, B, C bar, and then what? D. A bar, B, C bar, and then D. Here we have A bar, B, C, and then what? D bar. Here only A is appears complemented, so we have A bar, B, C, and what? D. So here we have A, B bar, C bar, D, right? Here we have A, B bar, C bar, and then D. Here we have A, B bar, C, D bar. Here we have A, B bar, C, D. Here we have A, B, C bar, D bar. Here we have A, B, C bar, and then D. Here we have A, B, C, D what? D bar, right? And the last one we have A, B, C, D. All appear what? Uncomplemented. Now, the idea of having the truth table and then having all possible combination is to make our work easier by identifying at what point our ones is going to be based on the examples. So at position 0, we can see that we have all but. So this is where our position 0 is. We are going to put our 1 in this cell, right? This is the position of our 1 in this cell, right? And then the next one is 3. Is 1 rather, 1. So 1 is given to be A bar, B bar, C bar. So let's look at A bar, B bar, C bar in our cell. A bar, B bar, C bar, and then D. So let's look for it. It's somewhere here. A bar, B bar, C bar, and then D. So this is where our 1 is going to be, like this. And then the next one is 3. At position 3, we have, so we have taken this, we have taken this. So the next one we are taking is 3. So at position 3, we have A bar, B bar, C, D. A bar, B bar, C, D. So this is where our 1 is going to be, right? So we have taken care of this. So the next one is 7. 7 is A bar, B, C, D. 7 is what? A bar, B, C, D. A bar, B, C, D. So at this cell, right? For 7, which is this. And then for 8, at position 8, we have A, B, C bar. That is A, B bar, C bar, D bar. So let's look for them. We have it at this position. A, B bar, C bar, D bar. So at this position, that's where our 1 will be, right? So we've taken care of 8. So the next one is 9. At position 9, we have A, B bar, C bar, D. We have what? Position 9, B bar, C bar. So we have it at this position where our 1 is going to be here, right? So we've taken care of what? 9. So the next one is what? 11. At 11, we have A, B bar. A, B bar, C, D, which is this, at this position, right? That is 9. Okay, 11 rather, 11. So we've taken care of 11 now, right? A, B bar, C, D, which is this. We've identified the one. And then lastly, we have 15, which is A, B, C, D, which is this, right? That's where our position of 1 is. So the next thing is to do the groupings. Remember, as the K-map rule, we are grouping based on the number of what? Ones. And then as part of the rule, try as much as possible to identify with the largest possible group of what? Ones. So by looking at the K-map, the largest possible group of ones that we can identify in terms of the grouping, our first grouping, we can see clearly we can have this as our first group, right? So we can pick this to be our first group as far as the K map is concerned. So we can call this, we can call this to be our group 1, right? Let's see. We have one here, one here, one here, one here. So instead of picking individual one like this, so we can have largest possible group, this, and then we can lab this with this, right? So that we can combine this with this, and then equally have group 2, right? So instead of taking them individually, we can wrap this with this and then have a single, group so that we can end up with just 2 groups, right? So with this now, we should be able to, simplify, right? Simplify our expression. So we can now say from what? From 1, which is the group 1, we have what? Let's see among the variables, what is changing and what is remaining constant. So looking at it from the variables given in this group 1, let's start with the first variable, that is A. So we have A bar in the first row, in the first cell rather, A bar, A bar, and then it changes. A bar changes to A at the third cell. So is going to be what? Discarded. You go to the next variable, we have B bar, and then in the second cell, it changes to B, right? And then you go to the next variable, which is C. Okay, C in the first cell remains is the same thing in the second cell, the same thing in the third cell, the same thing in the what? The fourth cell. So we are going to keep C, right? And then let's see what happens with the variable D. So in the first cell, it's still D. The same thing with D in the second cell. It didn't change. D didn't change. D didn't change. So we are going to have what? D. We are keeping C and D because it didn't change. They did not change, right? So let's see. From we are done with the first grouping. From the second group, which is group 2, right? So let's see across the variables what is changing, what is not changing. So A bar, it changes to A, right? B bar, B bar, B bar, B bar. So B bar remains constant. So we have B bar, right? So let's look at the next variable, C bar, C bar, C bar, C bar. So we have what? C bar, right? C bar again. Let's look at it again. C bar, C bar, C bar, and then C bar. So it remains. It didn't change. It remains constant rather. So D bar, of course, even from the first cell, it changes, right? So our final simplified expression is given as CD, right? CD plus what? B bar, C what? C bar, right? So of course, this can also be written as what? B bar, C bar plus what? Plus CD, right? To form our simplified expression. So see you in the next class when we'll be looking at the Queen MC class key minimization algorithm, which is also referred to as the tabular what method. Thank you.